Alrighty guys, good morning. We are going to do some more notes through our video today. So yesterday in class on our video, we learned how to take equations that were in standard form and put them into vertex form. And what was really nice about vertex form is it directly gives us our vertex. And so then we can use that to help us also find our x-intercepts. So we're going to do all of those same components today, except we're going to just take it one step further by putting our vertex and our x-intercepts onto a graph. And then we'll have a nice graph of a parabola. So today is nice because all of our equations are already in vertex form for us, so we won't have to do that completing the square process. We just need to identify what's our vertex and what are our x-intercepts. So looking at this equation, right, remember that the number on the inside of our parentheses with our x is going to give us the x coordinate of our vertex, but it's always switches sign, so that +2 would become -2. And the number on the outside of our parentheses, that -1, that's going to give us our y coordinate, and that sign is going to stay the same. So our vertex would be at -2, -1. In order to create a graph of a parabola, we need to know more than the vertex. If I were just to graph the point -2, -1 right now, I wouldn't know too much more. I don't know how skinny it is, how wide it could be, if it opens up, if it opens down, right? So we need to get a little bit more information, and that other piece of information that we are going to get is going to come from our x-intercepts. So anytime we are trying to find x-intercepts, we're always setting our y equal to 0. And that's because if I were to take any point right here along my x-axis, the y coordinate of any point that I pick would always be 0. So we're solving an equation now where y is 0. And the nice thing about vertex form is that we can just do our normal, like regular undoing strategies that we would do to solve any equation to get x by itself. So our goal is to make this say x equals, which means we're going to have to undo this -1, we're going to have to undo our square, and we're going to have to undo our 2. So very first step, add 1 to both sides. And in order to be able to get to this x plus 2, it's being protected by protected by these parentheses right now, and our square. So next step would be to undo our square by square rooting. So if we're looking at the right, a square and a square root, those are going to undo each other. So the only thing that we'll be left with on the right-hand side now is x plus 2. On the left, we have the square root of 1. And remember, yesterday we talked about how we always get 2 answers anytime we square root something. If we're thinking about what number times itself would give us 1, 1 times 1 would give us 1. -1 times -1 would also give us 1. So anytime we're square rooting a number, we're always going to get 2 answers, a positive version and a negative version. And that's going to end up creating 2 smaller equations that we'll have to solve, and each of those equations will give us one of our x-intercepts. So our very last step here would be to subtract 2. So one of our x-intercepts we're seeing is at -1. And if we subtract 2 from this equation, our other x-intercept is at -3. So putting those onto our graph, now we kind of have a better idea of how wide our parabola should be. So we can go ahead and connect all of our points. Let me make that a little bit better. And here's a graph of our parabola, right? We have our vertex, which we identified. Whoops. We have our vertex, which we identified first at the bottom, and those 2 x-intercepts right here at -3 and -1. All right. One more problem that we're going to do together, and then just like yesterday, you'll be trying some of those back questions on your own. Hopefully we're noticing on this question, it's a little different because we have this negative up front. So that negative isn't going to do anything to change our vertex, right? Our vertex will still be at -3, 2, because this turns into the opposite and this stays the same. This negative up front is causing our graph to open down, meaning that our parabola should look like an upside down U by the time we're done graphing. So hopefully that would make sense, because if we have our vertex right here at -3, 2, and our parabola were to open upwards, we wouldn't have any x-intercepts because it's never going to come back down and get low enough to touch our x-axis. So we should expect some x-intercepts if we're opening down. So let's set our y equal to 0. And we'll go through and solve, right? Very first thing we would need to do, subtract 2 from both sides. It might be really tempting right here to have your next step be to square root. But if we were to square root right now, we would run into some problems just like, I think it was number 4 yesterday, where we're having to take the square root of a negative, and if we put that in our calculator, that's not going to work out. It's going to give us what's called a domain error. If we're thinking of PEMDAS, which is our order of operations, before we can deal with exponents, because that's our square, right? If we're doing them in reverse to solve, we need to deal with multiplication and division. And so this negative right here is multiplication. It's really -1 times all of this stuff. So if we're trying to undo multiplying by -1, we would need to divide by -1. So those will cancel. -2 divided by -1 is going to make +2. And now once we have that taken care of, now we can square root both sides. So the square root of 2 will give us +1.41. Remember, it also gives us a negative version of that answer. So -1.41. On the right, our square and our square root undo each other. So we're just left with x plus 3. So again, we should have gotten 2 equations for 2 x-intercepts here. Last step would be to subtract 3 from everything. So x equals -1.58. And x will equal here -4.41. And those are going to be our x-intercepts. So we have one right here at like -1.5-ish, another one at -4.4. Connect our dots, and this is our parabola that opens down. So I want you guys to try out the back. I already have our answers pulled up, so I'll pause at each one. That way you can use those as a check if you get stuck. When you're done, the only other thing that you guys are working on today is CYU 15. We were supposed to do a quiz on this today. We will wrap that up when we come back from spring break. So write down any questions that you guys might have. That way we can go over them when we're back. But I hope you guys have a wonderful day.